Hello everyone, and welcome to our video on future value of an annuity, where we'll use the Tvm Solver to solve two examples. So an annuity is a sequence of equal payments made at equal periods of time. So say your cell phone bill. So you have to pay it every month. Okay, so and assuming it stays equal, kind of that's how it is now, where there's not really random charges, but who knows, maybe there are. But still, that's kind of like what's happening. An ordinary annuity, so this is how it's ordinarily done, or this is kind of how we usually do things, a sequence of equal payments made at the end of each time period. So again, kind of just like your cell phone, it's like maybe 30, 40, 20, somewhere around there, some type of dollar amount at the end of the month. So as soon as you sign up for it, they don't ask for that monthly charge right away. They might charge you with some other stuff, but no, it's at the end of the month is how it's normally done. Okay, and the future value of an ordinary annuity, so ordinary and annuity is like a payment. So this is the equation if you want to try it. All right, so it's got similar information. So if you do have these notes, it is, or if you're following, it's the same letters or similar letters as what we had for compound interest, but it's because there's a payment going in with it every time. We have it a little tweak to it. All right, however, the Tvm Solver that we introduced in previous videos will also work, and it's a lot faster and easier to work with. Okay, so let's see how it does work. So we have Cam deposits $1,000 at the end of each quarter for 18 years in an account paying 1.2% interest compounded quarterly. Find the final amount she will have on deposit. Okay, so we talked about in the last video as well, but as soon as you see something about compounding, that's where we want to use the Tvm Solver. And so that's where I use the free resource online. Okay, so I just type in Tvm Solver into Google, and then I usually prefer this GeoGebra one, because when you click on it, it kind of tells you what those important things are. And this is kind of similar to the 83, 84, or Inspire as well. So if you have a handheld calculator, it's got a similar setup. All right, so whenever I see that word compound, I just write all of these variables down. So we have N equals, I% equals, the present value equals, payment equals, a future value equals, and then our P over Y and C over Y, so a little squeeze, these should always be the same. So that's the compounds per year or the payments per year. And then future value, PMT is payment, okay, and then PV is present value, I% is the interest rates, and then N, we do have to make a little note. Remember, N is your number of times compounded times time. Okay, so it tells you the number of times something does get compounded. Okay, so let's break down this statement. So it says Cam deposits $1,000 at the end of each quarter. So this is a payment, so because it's saying at the end of each quarter, so that means that's a payment. So we'll put, all right, and let's add one other note with this. So we have, and it says it here too, again, in the calculator, it's kind of nice. Let me just go ahead and show it. That incoming cash are considered positive and outgoing are negative. So this would be outgoing because Cam is depositing this. So it's going out of her pocket and into the bank's pocket or whatever for at least a little bit. And then when she takes it out, then she would have incoming cash, and that would be considered positive. Okay, so often payments are negative. So payment, that's outgoing. So it's a negative value when we plug it into the solver. So we'll do negative 1,000 for our payment. And then it does say at the end of each quarter, so that would be payments per year. And then the compounds per year should be the same. And it says so in the problem. It does say compounded quarterly, so it does match. Okay, so this is our compounds per year. This was our payments per year. And again, they were the same at the end of each quarter. And then we can instantly put that 4 with the N, and then the number of years would instantly multiply it. So 4 times 18. in an account paying 1.2% interest. So put 1.2. Remember, this does not convert to a decimal. Just leave it as 1.2. And then it compounded quarterly. Okay, so I think that's everything. And then let's see. It says find the final amount she will have on deposit. So that means at the end of the 18 years. So that's we're trying to find a future value. And because there is no initial deposit, so there's no large, so it doesn't say, and what I mean by initial deposit, so it doesn't say like Cam deposits $10,000 and then $1,000 at the end of each month. So no, so there is no initial deposit, so we'll just say present value is 0. And then now that everything's filled in, we can use our solver, and we'll plug those in. Okay, so we've got our 4 times 18, and this can do it. 4 times 18, 72. And then moving on, 1.2. Our present value, we want 0. Payment, we make it negative 1,000. Future value is 0. And then these are each 4. And it automatically changes it for us. Okay, and then we wanted to solve for future value, so we'll click solve for future value. Where you have to click on it to make sure you see everything, because right now it doesn't show everything. So click on it to get all the decimals, and it looks like it's 80,233. And then 71 cents. Okay, so I couldn't remember the cents. 71. And there we go. That's it. That's the final answer. Find the final amount she'll have on deposit right there. Okay, and then they'll often ask this to follow up with these types of questions. So how much of the value is from contributions and how much is from interest? Okay, so we want to break these apart. Well, the interest here, so the interest that was earned is this future value minus the present value. Okay, so, or not the present value. Sorry. That is another formula that's important. Okay, so the future value minus the contributions. Let's just put it in words for now. So the future value minus the contributions. And the contributions is, okay, so we'll put this also to the side. Contributions is equal to, well, the number of times that she made the payment. So it is payment times the number of payments that were made. Well, she did it 4 times a year, the quarter, 4 times each year for 18 years. So that is just multiplying the payment times n. Okay, so our contributions in this problem would be 1,000. And at this point, we would just make it positive. So it's 1,000 times the number of times that the contribution was made. Okay, so which is the 4 times the 18. So that's in. And then from there, well, I'm going to use just the computer calculator that's right on my desktop right away. So 1,000 times the 4 times the 18 is 72,000. So over those 18 years, $72,000 of her own was deposited. Okay, so we have 72,000. I just put it there right away. Let me put it there too. Okay, but let me box that. So that's important for us. So the contributions is the number of payments times the amount of the payment times the number of payments. And then our future value, well, we just found, so $80,233.71, and then we just need to do that subtraction. Okay, so we already have the amount for the contributions, which I'll abbreviate. There it is. And then our interest is this difference. So we could just do that subtraction. Let's use my calculator again real quick. So the 80,233.71 minus 72,000. And we get 8,233.71. And they usually want you to round to the nearest decimal. So even on that contributions, you might need to, so let me unbox that, sorry. You might need to put 0.00 to show that it is rounded to the nearest decimal. It's 0 or the nearest cent. And there we go. Okay, so about $8,000 of interest was earned over these 18 years based on this payment for this compound amount. All right, so but the main thing is, as soon as you see the word compound, we're doing this in the calculator, and then from there we just have to interpret whatever the numbers are. All right, so let's see another example in this video. So in this example, it says Jimmy wants to pay off a $5,000 bond in 10 years. Find the amount of each payment to be made into a sinking fund, a fund set up to receive periodic payments, earning 4% compounded monthly. Okay, so in this scenario, so Jimmy wants to pay off a $5,000 bond in 10 years. We're assuming this $5,000 bond is going to stay $5,000 in the 10 years. So like this $5,000 doesn't have any interest on it. So that means he could set up this account to earn interest to help pay the $5,000 off a little bit more easy, in an easier fashion. Okay, so either way though, I see compounded and it's compounded monthly. So let's go ahead and get all of our variables ready. So in I%, present value, payment, future value, and then our payments per year and our compounds per year. So directly from the calculator. Okay, and then now we're just filling in our information. So Jimmy wants to pay off $5,000 in 10 years. We're going to find the amount of each payment to be made into a sinking fund, which is a fund set up to receive periodic payments. So we're trying to find, so let me underline that. So let me do it in purple. Find the amount of each payment. So that means this is what we find. And I'm just putting 0 there as a placeholder. So the payment is what we're finding. 0 is just a placeholder. And then it does earn. So I'm just kind of picking apart whatever I see. It's easy, 4%. So 4%, that's our I%. Compounded monthly means I could put 12 here, 12 here. And then I've got 12 instantly here times a time, which is that first information that I skipped over. Okay, so the 10 years I can see is right there. 12 times 10 would be that. Okay, and then now we just need to figure out, well, where does this $5,000 go? We're saying it's going to get paid off in 5,000 or in 10 years, the $5,000 in 10 years. So that means this is a future value. Okay, so we'll just do $5,000 right here. Okay, and that means currently, so we're trying to find the payment, and then there is no initial present value, so what's 0? So he's not paying off any of the bond at all. He's going to wait until 10 years to do it. So everything's ready, and then now we can find this payment. So now it is going to be, so I'm just going to set it up, payment equals. So you could skip ahead if you feel good about it at this point, but this will be the answer. But let's go through the calculator to show everything. Okay, so we've got 12 times 10, and then 4. Present value is 0. Payment, we'll do 0 as a placeholder. Future value is the $5,000. And then here we go 12. Here we go 12. And then so we wanted to solve payment. So right here we click that button and it says it's $33.96. Remember, the negative is just saying like it's outgoing. Okay, so every month this is the amount that's going into this account. But that would take care of it. Oops. So we've got, let me see it again. Just, yeah, $33.96. Okay, so what's happening here? Let's look at the calculator real quick. So $33 times and 96 cents times the number of times that payment would have been made, which is 12 times 10. So 12 months in a year for 10 years. And so we're seeing, oh, he really is he's just actually kind of paying only $4,000 because the amount of interest that he's earning is going to take care of the rest. Okay, so that 4% is a high interest rate. Okay, so it's a good deal for Jimmy to do this. All right, anyway, that's how we can break down these problems. Okay, so these other ones, so I've got another video with 3 other problems. They all are TVM Solver, so if you're feeling good about these, I mean, you could try them on your own. Just make sure you're feeling comfortable enough. So, I mean, I hope it looks easy, but just make sure to get the actual practice in to do it. All right, and then if you do have questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.